Hello. So, good evening, everyone. I am Orko Shah from IIT Kharagpur, and I am right now I'm working under Sridhar Prabhuraman sir for in a project like neural network for estimation of transmission loss in the Indian Ocean region. So I am joined this company. Like almost 1 month back, and I have progressed I have progressed in this project quite a bit. So I would like to present my work. Yes. So this is my introduction, and I have given it. And after this, like going ahead, like what is my work I have done till now? Like so, it is like calculating the transmission loss for the sound wave propagation in and the maritime trafficking tracking with AIS data. So, what is underwater acoustic propagation? So it is a critical for maritime defense communication and navigation, especially in the regions with the Indian Ocean region and have a complex seafloor terrain and strategic importance. And by this, like we can ensure continuous situational awareness in the underwater environments, which is like essential for like submarine detections, like acoustic surveillance and like safe navigation source. And after this, like transmission loss, like represents like what is transmission loss actually, what is like I have worked on, like it represents like how sound energy is lost during propagation. So like accurate transmission loss prediction like enables better sonar range estimation and like underwater communication and submarine detections. And other thing for this, like I have worked with like AIS data. So it actually enables real time ship trafficking by broadcasting vessel identities, positions, and their related everything, like what is the ID of the ships, and everything is present in that data. So when like we have integrated this with the acoustic transmission loss prediction, and like it allows authorities to estimate underwater acoustic visibility of vessels and sonar plannings, maritime securities operations, and all this. So like moving ahead with this, and like AIS data, like what is AIS data? It is actually like automated identification system, which is actually used for the continuous tracking of vessels locations, speeds, and headings and all that. And we have like combined this AI's data with the transmission loss estimation, and we can enhance this underwater visibility assessment and like early detection of like stealth vessels and the maritime situational awareness, all this. And moving ahead, like what is actually my problem statement is, like what problem statement I have working on. So it is actually for estimating the transmission loss for for yes, for the estimating the transmission loss, we have like already we have actually a pre-existing models exist, which is a PRAM method, which is actually a parabolic equation based method, which is like very uh, mathematically heavy model. So it takes a lot of time to calculate the transmission loss. Like we want to calculate transmission loss for around like 300 ships, which is present around a single receiver. So it will take quite a lot of time, and it is very computationally heavy. So like with this, uh, maritime surveillance needs like faster acoustic prediction to track and respond in real time, and which actually enables us to think like machine learning solution, which is very fast, and like the accuracy is almost like the our true transmission loss. So we have gone for these machine learning models. So so, like what is our approach to what is our approach for this work? So first of all, like we have collected a data set with like transmitter and receiver coordinates, like the latitude longitudes of the transmitter and receiver as well, and like depth, frequency and bathymetry data and all, and like other sound speed profiles also. Like sound speed profile is like what is the speed of the sound beneath under a ship, like at what depth what is the speed of the sound. Like as the depth increases, my speed of the sound also increases with this. So it is we have also worked with this data as well, and like used ground truth transmission loss generated by PRAM method, and like based on this data we have like trained our machine learning model. And this model like includes like various models like artificial neural network, random forest, LSTM, linear regression. So these are like all the machine learning models. So in this we can we will I will say I will like show the like in the overall with this model, like the artificial neural network works very well for this based compared to other models that I have used or I have tested. So like going ahead, and like this is the overall like Indian Ocean region for which we have collected our AIS data and all, and based on this data I have worked on my machine learning models and all. So like these are the evaluation results, and like we can see like the LSTM models here actually like performs very poorly in our data set, and it is like as expected, like this data is not very sequential in nature, so it will work very poorly. We can see like artificial neural network it is like has given us very accurate accuracy score like 93%, which is almost good enough for us. And like other and another model like we have also focused on like the random forest model, which performs well than the artificial neural network model, but the thing is it is like very slower for this compared to like artificial neural network model. So we have like gone with the artificial neural network model because it is fast enough, and like it also like produces good accuracy score. We will like want to improve this model with other technologies and all. So like moving ahead, like and this is the like time comparison for the PRAM model with the artificial neural network model. Like the pre-existing model, it actually takes a total time of like 296 seconds, almost like 300 seconds for for calculating a sample of like 3000 samples or 3000 data points. So it is taking almost like 300 seconds, and whereas compared to the ANN model, it is almost taking like 0.36 seconds, which is like which tells us like the neural network is almost 800 times faster than the PRAM model. So it is like very efficient and like prominent idea for implementing this model into our system. Uh, like and yes, this is the graph which we get from the by comparing the PRAM model with the machine learning model or the ANN model. Like this red line is the accurate prediction of what our transmission loss should be, and these blue lines are like the predicted transmission loss for our machine learning for the for like these are the predicted transmission loss by our the ANN model. So like it almost like works very well for us, but still improvement is also need for this. And like going ahead, like and like and like why this research matters actually. So like the transmission propagation or the acoustics is very important in the maritime domain. So it actually needs to like track every vessels and other like maritime environment activities. So with the sound wave propagation, it's like one of the way. I'm not telling like it's the only way, but it's the one of the way. So like it enables like a real time sonar planning. So like our neural network model can predict the underwater sound transmission loss almost instantly, and allowing naval operators to dynamically plan sonar coverages zones during operations without delays caused by traditional simulation. And like other thing like enhance vessels tracking using AIS integration, I have told earlier, like by integrating AIS data with our transmission loss prediction system, we can evaluate how visible a ship is acoustically. And like other thing also like supports fast and informed naval decision making. Like yes, estimation empowers naval commanders to and centers to responds quickly to potential threats or changes in the maritime environment, and like improving situational awarenesses and operational readiness also. And other thing like scales across ocean regions and frequencies, like we have only worked with the four kind of frequencies ranging from like 100 frequency 100 hertz, 200 hertz, 300 hertz, and 400 hertz. So I have worked on these four frequencies for this project. And like what is the future scope for this, and what improvement can be done? Like one improvement we I have already told key, we need to increase our accuracy of our model further. So this is one like one improvement we can done. And other things like we can extend our model for 3D transmission loss mapping, and with like more depth granularity. And other things like integrating directly with the AIS and sonar systems, apply the model to the oceans and frequency band for various frequencies bands. As I have told, I have only used this for four frequencies. And other thing like we can combine with satellite data for autonomous underwater planning systems and all. Yeah, so thank you for this. That's it from my side.